This is recitation 1, problem 2. Problem 2. For the second problem, we will have our coordinate system x and y. We will have charge q1 at the origin. We will have charge q2 at point x, A. And what we are interested in force exerted by these two charges on charge q3 that is at point y equal to minus b. And let's put charge q2 as negative. So q2 is negative. Well, we are looking for the force exerted on the charge q3 by these two charges. We will use Coulomb's law that tells us that force between two charged particles, I put magnitude of force, is coefficient k, then magnitude of charge 1, magnitude of charge 2 divided by distance between them squared, magnitude of force. And we will use principle of superposition. So we will find force exerted by Q1 on Q3. We will call this force F1. So force on Q3 will be F1 plus force exerted by Q2 on Q3. We will call this force F2. And let's draw these forces. So I draw the forces applied to Q3 charge of interest. Force exerted by Q1 on Q3 will be a repulsive force because both charges are positive. So this force F1 will be down. And force exerted by Q2 on Q3 will be along this line, and it will be attractive force. So this is F3. F3. Now we need to find F1 and express it in terms of components. We need to express in terms of components force that we call, I made a mistake here. This is F2, and here it was right, it is F2, F1 plus F2. So we need to express F1 in terms of components, we need to express F2 in terms of components, and then add these two forces as vectors. So what is F1 in terms of components? F1 has 0x component, y component is negative, so it is minus k, then product of charges, magnitude of q1, magnitude of q3, divided by distance between them squared. Distance is b, so this is b squared, and this will be y component, x component is 0. So now for F2, F2 has both components, x and y components. Let's draw a right triangle to project F2. I draw a line perpendicular to y. This is 90 degrees. So F2 is vector. F2 is vector sum of these two vectors. Then x component is positive and y component is positive. X component of this vector F2 will be magnitude is k, and then Q2, Q3. I don't put minus Q2 here because I remind you that this is magnitude of Q2. So it's magnitude of Q2, magnitude of Q3 divided by distance between them squared. What is distance between them? I will use this right triangle to find the distance. This is hypotenuse of this triangle. And this is A. This is B. So hypotenuse will be A squared plus b squared square root, but we have distance squared, so it will be a squared plus b squared, distance squared. And now I need to write x component of f2. So we need to introduce angle. Which angle will we introduce? Let's introduce this angle theta. If this is theta, then for x component, I will have, this is my x component, I will have f2 times sine theta. Sine theta. And this will be ix. Since we introduce angle with vertical, it's sine theta. And then plus y component is also positive. And for y component, this angle is adjacent angle. So I will put k. It is positive, so it is plus here. Now magnitude of q2, magnitude of q3 divided by distance between them squared, a squared plus b squared. For y component, I multiply by cosine theta because theta that we introduced is adjacent angle, iy. So now I need to express sine theta and cosine theta in terms of what is given. Sine theta, which triangle we will use? We will use this big triangle to find sine theta and cosine theta. This is my triangle. And sine theta is opposite leg, which is a, divided by hypotenuse, which is square root of a squared plus b squared. And cosine theta is equal to adjacent leg, which is b, divided by square root of a squared plus b squared. So what is my final expression for f2? f2 is equal to k, q2, q3, divided by a squared plus b squared, times sine theta, which is a, and then square root of a squared plus b squared will give me a squared plus b squared to 3/2, 1 plus 1/2. And this is x component of f2. And then it is plus k, q2, q3, divided by a squared plus b squared. And cosine theta is b, and then square root of a squared b squared. So here we'll have a squared plus b squared to 3/2 iy. Now we have f1 and we have f2. All we need to do, we need to add f1 and f2 as vectors, which means that we add x components and y components. X component of f1 is 0. So then x component of f2 is right here. It is k, q2, q3, a, divided by a squared plus b squared to 3/2 ix, plus, now we add y components. Y component of f1 is negative, minus k q1, q3, divided by distance b between squared b squared, and y component of f2 is k, q2, q3, b, divided by a squared plus b squared 3/2, and we don't forget iy. This is y component of the resultant. I forgot to close my bracket. Let's do it. So I close the bracket, and this is iy component of the result. So this is our final answer. Fourth exerted on Q3 by two charges, Q1 and charge minus Q2.